Hello all and welcome to this session of trigonometry of compound angles. So let's start trigonometry of compound angles. Compound angles involves the addition and subtraction of two or more angles. Addition and subtraction identities. So let us consider one by one some important and basic identities which we shall be using and seeing their application in solving the problem. The first one is sine of A plus B is equal to sine A cos B plus cos A sine B. So when two angles are added, then the identity is sine of A times cos of B plus cos of A times sine of B. And if it is subtracted A minus B, then we will have a subtraction minus sign here. This should be noted. For plus, it will go for plus. For minus, it will go with minus sign. Again, the next one, let us take cos of A plus B is cos A cos B minus sin A sin B. Here in place of cos A plus B, it is cos A cos B minus sin A sin B. And if it is cos of A minus B, it becomes plus. The third one is for tan. Tan A plus B is tan A plus tan B upon 1 minus tan A times tan B. And in case of minus, this will become minus and this will become plus. So these are actually 3, or you can say 6 basic and very important identities with addition and subtraction of angles. These are very important and one should learn it. Now let us take few examples based on this. Example 1. If cos of A plus B times sine of C minus D is equal to cos of A minus B times sine of C plus D, then prove that tan of A, tan of B, tan of C plus tan of D is equal to 0. So this is given cos of A plus B times sine of C minus D equals to cos of A minus B times sine of C plus D. We have to prove that tan A times tan B times tan C plus tan D is equal to 0. Let's see the solution. Let's take this side. Cos A plus B times sin C minus D is equal to cos A minus B times sin C plus D. This is what we have. We have to start with this and try to get this. So what I'll do, I'll just take this sin C minus D this side and bring cos A minus B this side. So what it will become? It will become cos of A plus B upon cos of A minus B, because this cos of A minus B has been brought this side. Now this side what we are left with is sin C plus D upon getting this sin C minus D this side, it is sin of C minus D. Now using a property, using componendo and dividendo, we will have cos of A plus B plus cos of A minus B upon cos of A plus B minus cos of A minus B is equal to sin of C plus D plus sin of C minus D upon sin of C plus D minus sin of C minus D. This is the property of componendo dividendo. Making use of this property, we will work out. Now, this will become just expand this using the identity. Now, this is cos A cos B minus sin A sin B plus cos A cos B plus sin A sin B. I have just opened this and this according to the given identities. In denominator, in same way we will expand this cos A cos B minus sin A sin B. This is minus here, so minus cos A cos B plus, because of this minus it will become again minus sin A sin B equals to, this also is to be expanded in the same way using the identity. This is sin C cos D plus cos C sin D plus sin C cos D minus cos C sin D upon sin C cos D plus cos C sin D minus sin C cos D. This should be minus here, because it is minus here, again I will put plus here. So this is cos C sin D. Now see, minus sin A sin B plus sin A sin B, this will get cancelled. Here in this case, you will have sin A sin B, sin A sin B, cos A cos B cos A cos B, this will get cancelled. So you are left here with twice of cos A cos b in the numerator, cos a cos b cos b upon minus twice of sin a sin b, and this side, this will get cancelled with this, and here this and this gets cancelled. You are left with 2 sin c cos d upon 2 cos c sin d. Cancel out these 2's, and next we have to get tan a, tan b, tan c. Now this is cot a, cot a, cot b equals to tan c cot d. Let me just convert entire thing in terms of tan. This becomes 1 over tan a tan b, this is tan c, and this is tan d. Or if I rearrange, I get tan a, tan b, tan c equals to minus of tan d, or tan a times tan b times tan c plus tan d is equal to 0. This is what we had to prove, and thus this is our final answer. Let's take another question. This is a very important question. Find the value of cos 75 degree. This is our example 2. Now for solution, cos 75 we can write as cos of 45 plus 30, and here we can use the identity cos a cos b minus sin a sin b. Use their values, standard values. Cos 45 is 1 over root 2, and cos 30 is half, and this will be 1 by root 2, sin 30 is half. This is actually root 3 by 2. Now simplify this, we get root 3 minus 1 upon 2 root 2 multiply by root 2 and root 2, that gives you root 6 minus root 2 upon 4. This is our answer. Let's see next question. Example 3. Prove that cos pi by 4 minus x times cos pi by 4 minus y minus sin pi by 4 minus x times sin pi by 4 minus y is equal to sin of x plus y. Now let's solve it. Solution. We know that cos A cos B minus sin A sin B is equal to cos of A plus B. Now let pi by 4 minus x be A and pi by 4 minus y be y. Then the equation becomes cos A cos B minus sin A sin B, which is cos of A plus B, that is cos of pi by 4 minus x plus pi by 4 minus y. This is cos of pi by 2 minus of x plus y, which is nothing but sin of x plus y is our answer. Let's take up the next question, which says example 4. Rewrite fx equals to 4 times sine 3x plus pi by 3 as a sum of sine and cosine. Means we have to express this as sum of sine and cosine. Let's see the solution. Now 4 of sine 3x plus pi by 4 is equal to 4 times sine 3x cos pi by 4 plus cos 3x times sine pi by 4. Now put the values. You will get 4 sine 3x and cos pi by 4 is 1 by root 2. sorry, this is pi by 3. So I will just, it is pi by 3, pi by 3 and pi by 3. Pi by 3 is 1 by 2 cos 60, 1 by 2 plus cos 3x sin 60 is root 3 by 2. Root 3 by 2. This gives us 4 times sin 3x plus root 3 cos 3x, and we get this 2 with this, and we are left with 2 times of sin 3x plus 2 root 3 cos 3x, which is the sum of sine and cosine, and is the answer. Let us take another question, which is also an important question. This is example 5. An angle theta is divided into two parts so that the ratio of the tangents of the parts is k if the difference between the parts be phi. Prove that sin phi is equal to k minus 1 on k plus 1 of sin theta. This question is a very important question and it is application based. So just pay attention to the solution. So solution, let theta be divided into two parts alpha and beta. Let alpha and beta be the two parts of theta. So according to question, alpha plus beta is theta and the difference of the two parts is phi. So alpha minus beta is phi, right? Taking alpha greater than beta. Okay. Also it is given that tan of alpha upon tan of beta, the ratio is k is to 1. Now let me just convert it into sine and cos. So this becomes sine alpha on cos alpha, and in the denominator tan beta will become sine beta upon cos beta, which will go up cos beta This is k by 1. Now again, using componendo and dividendo, what we will do? Numerator plus the denominator by numerator minus the denominator, that is sine alpha cos beta plus cos alpha sine beta upon sine alpha cos beta minus cos alpha sine beta, and this side it will be k plus 1 upon k minus 1. Now this, again, using the identity, this is nothing but sine of alpha plus beta, and this is sine of alpha minus beta. This is k plus 1 by k minus 1. Now as we know that alpha plus beta is nothing but theta, so this is sine theta, and this is sine of phi, which is k plus 1 on k minus 1. Rearranging, we get sine phi is k minus 1 on k plus 1 times sine theta. This is our answer. So this is an important question and you should know it. Quickly we will take another last question. If this is example 6, if a plus b plus c is pi, that is 180 degree, and cos a is equal to cos b times cos c, then prove that tan b times tan c is equal to 2. This is also an important question, and let's see the solution. We have a plus b plus c equals to pi. That implies that b plus c is equal to pi minus a. Now taking cosine of both the sides, I will get cos of b plus c is equal to cos of pi minus a. Cos of 180 minus a is nothing but minus cos a. Now using the identity, this becomes cos b cos c minus sin b sin c is equal to minus of cos a. Now it is given that cos a is nothing but cos b times cos c. So I'll write it here, cos b times cos c. Now rearranging, we will get, if I get this side, twice of cos b cos c is equal to sin b and sin c. Again, taking this cos below this, we get sin b times sin c upon cos b times cos c is 2, which is nothing but tan b tan c is equal to 2 is our answer. Thank you very much, and we shall continue the other part in the videos to come next. Any doubt, you can message me, write it in the comment. I'll try to solve it. Thank you very much. Have a nice time.